Hello, Algebra 2 students. Today we are doing 7.4 notes, evaluate logarithms and graph logarithmic functions. So in section 7172, you learned what exponential growth and exponential decay functions are. And so this section will kind of tie those sections into this one, kind of. So what is a logarithm? Well, logarithms allow you to find x. If, for example, you have an exponential equation like 2 to the x power equals 6, what number multiplied by itself, um, or 2 multiplied by itself, how many times gives you 6? And of course, it's not going to be an exact value, but logarithms helps you calculate this. So it allows you to find an exponent. Here is how you read the following. Log base b of y is equal to x. That is how you read it. You don't say log by. So log base b, that subscript number is called a base. And you can go from logs to exponents and exponents to logs pretty easily. And that's what we're going to do at the very beginning. So log base b of y is the exact same thing as y equals b to the x power. Examples of logs are used in Richter scales, pH scales, if you're talking about acids, bases, all that stuff. So you'll use logs in chemistry. Let's do some examples. In example 1, we have to rewrite the equation in exponential form. Pay really close attention. Once you get the hang of it, it's actually fun and it goes by pretty fast. So the little number 2 is the base, so you start with it. So the base is 2, the exponent is 5, that equals 32. And that's how you go from a log to an exponent. It means the same thing. So the moral here is little b is your base, so that's the smallest number 2. And then the number across the equal sign, that's the exponent. So 2 to the 5th equals 32. Next one, 10 is your base, 0 is your exponent, that equals 1. And verify it, 10 to the 0 does equal to 1, 2 to the 5th does equal 32. Next one, this 9 is your base, 1 is your exponent, and that is it. And then the last one, when you have a fraction base, don't leave it like this is wrong, because you have more than one term. Write that base in parentheses. So the base, 1/5 raised to the negative 2 power, gives you 25. Now you're probably thinking, is that true? Let's verify it. This is a great way to review properties of exponents. Distribute this exponent to each base. So you have 1 to the negative 2 power over 5 to the negative 2 power. Can't have negative exponents, so we are going to put the 5 squared here and the 1 squared down there. And that is 25. So it does work. Okay. In example 2, we are going to evaluate logs. So we have to first write it into an exponential equation and then simplify. So in these particular example, you're going to ask yourself, b raised to what power gives you x or y or z or whatever you want to. Okay. So we are going to take our 3 as our base, and you're just going to think that this side is equal to x. So that's basically why I'm going to choose x as my variable. So 3 to the x power equals 81. Now this one's common sense. 3 multiplied by itself, how many times gives you 81? But I want you to be aware of doing these problems a certain way because it's going to help you do B, C, and D. So the way you want to write it is the bases have to match up. So on the left side, the base is 3. On the right side, the base better be 3 also. And it has to be. So 3 to the 4th is 3 times 3 times 3 times 3, and that's equal to 81. When the bases match up, you set these two equal to each other. Because remember, this equal sign right here tells you can do that. So you have x equals 4. And that is your answer for x. And so that's how I want to do B, C, and D. So 1/4 is your base. Put an equal to x here, or y, or whatever you want to call it. Raised to the x power equals 256. Okay. Now, for this one, you just have to know that 1/4 is the reciprocal of 4. So when you're going to write that, if you're going to use the reciprocal, and you're going to put the 4 in the numerator, then the exponent has to be negative, because you're moving the 4 to the top. And then you have the x there. And here you're going to have to use the base of 4. 4 to what power gives you 256? Use a calculator for trial and error if you don't have these memorized. It's 4 times 4 times 4 times 4 gives you 256. Now that the bases are equal to each other, you can set that exponent equal to that. So negative 1x equals 4. Divide by negative 1, x equals negative 4. Okay, our next one, base 10 to the x power equals 0.001. 10 to the x equals. Now, remember, you read that's in the thousandths place. So you're going to move the decimal point 3 places to the right. And when you have such a small decimal, that's a negative exponent. So 10 to the negative third is the same thing as 0.001. And now that the bases are equal to each other, the exponents are equal to each other. X equals negative 3. Okay, and our last one. 64 is our base. X is our exponent, equal to 2. So 2 is going to be our base, not 64, because 2 is small. So here we are going to write 64 using a base of 2. So 2 multiplied by itself, how many times gives me 64? Well, 2 to the 5th is 32. So 2 to the 6th is 64. And so that's 2 to the 6x equals 2 to the 1st. Remember, that's just 2 to the 1st power. And now you can set the exponents equal to each other. Divide by 6. X equals 1/6. Can't use a calculator on this. You must show your work. Okay. Now, common logarithms. Logarithms that are known as common logs have a base of 10. And when it's base 10, you don't see the number 10 written there. Sometimes you might see it, but 99.9% of the time, the 10 will be left out. You just have to know that that's a base of 10. You'll just see the word log. And so when you see the word log, that's base 10. It's common because our number system is base 10. So there it is. A natural log is a logarithm with base e. And you learned about the number e when you did your notes in 7.3. So any log with a base e is called a natural log or log base e. So base e. If you don't see the letter e, it's understood. So it's right here. It's just everyone knows that natural log has a base of e and a common log has a base of 10. So that's just something you have to remember. All right. Use a calculator to evaluate the logarithm. Log 0.85. So I'm going to basically do this as we would be doing it on our phone. So if you're going to use your phone, you would just go to your calculator, tilt your phone sideways, punch in 0.85, and then you would hit the log button. And the log button, so these are the steps. So enter 0.85, then key in this button on your phone that says log base 10, and that will give you your answer. And then equal. So you get negative 0.0706. That looks pretty good, rounded to 4 decimal places. And now let's do natural log. So natural log 22. So key in 22 first. And then hit the ln button. And honestly, you don't even need to put an equal sign because it gives you the answer. So that gives you, so don't do an equal sign, probably not here either. So, and that gives you, hold on, 3.0910. I'm going to double check on the first one. So if I did 0.85 and then hit log base 10, it gives you the answer. But if you try to hit equal, it's okay. For this one, it was okay. Right. Okay, for this second part, so that's the first part, just how to evaluate logs with a calculator. This next part, inverse functions. Going back to inverse functions, we knew f of g of x had to equal x and g of f of x had to equal x. So as far as logs go, if g of x is equal to log base b of x would be the inverse of the exponential function y equals b to the x. Remember, it's just a fancy. So basically, in y equals b to the x, if I was to change x and y, so switch x and y, and then I would have to rewrite that equation. I'm going to write it in log form. Remember, your base is b, because that's your base. A base is always raised to an exponent. And the exponent goes on the right side of your equal sign. And notice this is the same thing as that, because g of x just means y. So g of f of x would have to equal x, and this is what it looks like. Log base b of b to the x equals x. And then f of g of x, b log base b of y, or log base b of x, is equal to x. It's kind of confusing. And honestly, I'm not too worried about you knowing how to do examples 5, A and B, but I do expect you to be able to do example 6. So we're going to go ahead and do example 5. So e to the ln of y. So this is what the problem would look like. So natural log base e of e to the ln of y. That's basically what that problem is, and you kind of need to know that. And then honestly, everything cancels except, now that looks just like this. And then the only thing remaining is that 9. So again, I'm not going to include any of these on a test. Basically, all of this cancels except the 9. It's a little tougher. Next one, log base 3. I'm going to write 27 as 3 to the third power. And then you have that x there. So everything cancels here, and you're left with just your exponent. Kind of tough. But like I said, don't worry about example 5. Worry more about example 6. We've done inverses before. What are the 2 steps of finding an inverse? Step number 1, switch x and y. Step 2, solve for y. So let's do number 6a. So y equals 8 to the x power. We are going to first switch x and y. That's easy. Everybody can switch letters. But can everybody do step 2? That's the key. So step 2, we need to take that equation that's been written in exponential form and write it into log form. Then you need to know what numbers are. So the base is 8. The exponent is y, so it goes on the opposite side of the equal sign. Well, then the only letter remaining, there you go. And you solve for y. Y equals log base 8 of x. As long as you get y by itself, you're golden. Okay, for the next one, step 1, switch x and y. Now here, this takes a little bit of thinking. What is the base? And hopefully you remember, oh, if it's natural log, the base is going to be e. Put it in there. There's no shame in putting it in there. And so now that can help you write the equation in e form, base e form. So this time, look at b. B is in natural log form, so you need to write it in exponential form. If an equation is in log form, you need to write it in exponential form. So e is your base, raised to the x power, gives you y minus 4. Okay, and then all we have to do is add 4 to both sides. e to the x plus 4 equals y. You got y by itself. So the whole first part of 7.4 was evaluating logs. The second part of 7.4 is graphing logarithms. So if we look at logarithms, on the both of these graphs, the red graphs are your log graphs. The blue graphs are your exponential equations. So the blue one, exponential functions and logarithmic functions are inverses of each other. And the reason why they're inverses, because they are reflected across that line y equals x. This is your y equals x line. And this is, remember, y equals b to the x. And this one is y equals log base b of x. And so all I want you to do is just take note that for exponential functions, the blue graph is above the x-axis. So your range is y greater than 0, but your domain is all real numbers. For the red graphs, notice that your y-axis is your asymptote. So your domain is x is greater than 0, and the range is all real numbers, positive and negative numbers. And you'll see that easier when we're actually doing the examples. So let's take a look at graphing some. So we are going to graph some basic ones, and then we'll graph one that has been shifted. So this first one, example 7a, we are going to graph log base 3 of x equals y. So the first thing we need to do is we need to take that log equation and write it into exponential form. So 3 is our base. Remember, base, exponent, and then that's x. So that's your answer. So 3 to the y power equals x. Okay, now step 2, choose y values. Why do you choose y values? Because you do exponents first. So it's kind of odd because we're always used to picking x. So we're going to pick y values. I'm going to pick 0 because I know 3 to the 0 power is 1. I'm going to pick 1, 2, and let's pick negative 1. Even though I don't have a spot for it, we want to pick negative numbers as well. Now I'll put negative 2 here. Whether I use it or not, it's a different story. Okay, now replace your y values into your equation. 3 to the 0 is 1. 3 to the first power is 3. 3 to the second power is 9. And then replace this negative 1 right here. And let's do the work down here. So 3 to the negative first, because I know you guys have problems with negative exponents. That's 3 to the negative first is the same thing as 1/3. You're just going to put the 3 in the denominator. So it'd give you 1/3. And I'm not going to go do 2. But if you did 3 to the negative second, it'd be the same thing as 1/3 to the second, which is 1/9. But we don't need to do it. Okay, and we can go ahead and sketch in our asymptote. So I'm going to do that. So this time, exponential functions had horizontal asymptotes. Logarithmic functions have vertical asymptotes. That is x equals 0. Okay, now we are going to plot our points. So we have 1, 0, 3, 1, 9, 2, and I'm going to go ahead and plot 1/3 comma negative 1. Somewhere over here. So here is our graph. It's going to get closer and closer to the red line, but it's not going to go over. It's going to taper off. And that is y equals log base 3x. And the domain is, remember, just your x values. X has to be all positive numbers. So greater than 0. Can't include 0 because that would give you an error message. And you cannot include 0 because it's your asymptote line. And the range, notice y values are positive, negative, and 0. So it's everything. All real numbers for y. Go. Okay. Let's do example number 2. In example number 2, we are going to write our equation as 1/2 is our base raised to the y power gives you x. Choose y's. Again, I would be crazy not to use 0 because we know anything to the 0 power is 1. let's pick a negative. Let's pick a couple of negatives this time. Let's pick a positive. Okay, let's start with negative, or let's start with positive 1. 1/2 to the first power is just 1/2. It's easy. And now let's do 1/2 to the negative first. So I will do it right here. So that would be distribute the exponent to each base and then switch the positions. And that's 2. Let's do the same thing for 1/2 to the negative second. So it's 1 to the negative second over 2 to the negative second. Switch, make the exponent positive, and that's 4. And let's go ahead and sketch in our asymptote and then plot our points, connect the curve, and then list the domain and range. So plotting our points, we have 4, -2. So 4 down 2. We have 2, -1. 1, 0. 1/2, 1. This time, the graph is approaching the x-axis closer that way, but going further out this way. And our domain, again, x can only be positive numbers. You can look at your table, verify it. You're never going to get a negative number for x. And your range includes everything. Right. And our last problem. So our last problem, we're going to involve movement, horizontal and vertical movement. So going back to our best friend h and k, h means you're moving horizontally, k means you're moving vertically. So horizontal translation, and also remember h is opposite in your equation, and k, you keep k. No matter how many times I say it, students still don't get it. So a positive k in an equation would mean that you're actually moving left. A negative h means right. K, luckily you don't have to worry about being opposite. A positive k means you're moving up. Negative k means you're moving down. All right. What are the steps of graphing a log function that has h and k involved, or just h or just k? Step 1, you graph the parent function, which is just the basic y equals log base b of x. Then step 2, you translate points left or right, h, then up or down, k, and then 3, connect in a smooth curve. I actually like doing these. This really makes sense. It really, really does. So let's take a look at our function here. The plus 3 tells us that we are going to move left 3. The plus 1, you keep it, so up 1. So you just have to remember that. Just because you see x plus 3 doesn't mean you're going to move right. You're moving left 3, and therefore, since you're moving left, h is -3. So h is -3. K is 1. Okay, and now we did that. We got that out of the way. Let's graph the parent function, or not graph it. Let's write the equation for the parent function. Oh, this says graph the parent function. We're not going to graph the parent function. We're going to skip that. We will actually graph the function. So we won't graph it. We'll just make a table for the parent function. So let's see. Instead of graph, make a table. Right. So the parent function is y equals log, the base is 2. We're just going to keep the simple x. We're going to act like there's no plus 3 or a plus 1. So that's just for the parent function. So then we are going to rewrite that into exponential form. So that would be 2 is your base, raised to the y power equals x. Choose y values. So I'm going to pick 0, 1, and 2. It doesn't matter if you don't pick negative numbers. It really doesn't matter. And then we are going to find what x is. So replace each of the numbers for y in your equation right here. So 2 to the 0 is 1. 2 to the first power is 2. And 2 to the second power is 4. But we're not going to graph that. We are going to now make a table for the translated function. Notice what I said. you move left 3, up 1. So let's write that down here. Left 3, comma, up 1. Because left 3 deals with x and up 1 deals with y. So take your x coordinate, which is 1, subtract 3, take your y coordinate, which is 0, add 1. Super easy. So next row in the table, take 2, subtract 3, take the 1, add 1. And the last number, take your 4, subtract 3 because you're moving left 3, and take your y coordinate 2 and add 1. And now your resulting answers go in our new table for the graph. So 1 minus 3 is negative 2, 0 plus 1 is 1. 2 minus 3 is negative 1, 1 plus 1 is 2, 4 minus 3 is 1, and 2 plus 1 is 3. And we are going to use those as our graphs. However, before we go any further, I'm going to have you put an arrow here. Make a little spot here for, even though I'm not asking you, for your asymptote. Put an arrow there, and then put an arrow next to the domain. Hopefully this brings back memories of when we did exponential functions. I said, once you knew what k was, k tells you your asymptote, and k tells you the range. Well, now with logarithms, you're using the h. You're going to use the asymptote, and you're going to use the domain. So once you know what h is, that is going to be your asymptote. So your asymptote, but instead of y, it's going to be x. So x equals negative 3. And therefore, your domain is x is greater than negative 3. And your range is just all real numbers. And that takes care of that. And you draw in your asymptote first. So I'm going to sketch in x equals negative 3. I'm going to find negative 3 on my x-axis. So 1, 2, here's negative 3. I'm just going to put a little dot, but then I'm going to put a dashed line or a squiggly line. There we go. I'll label it. So your graph cannot cross that line under any circumstances. Now we're going to plot the points. So negative 2, comma 1. Negative 1, comma 2. 1, comma 3. What if I had used 4 or whatever? Then so be it. But you can see how the graph's going. It's increasing that way, but decreasing this way. And that is your graph for y equals log base 2 of x plus 3 plus 1. And you know what? I think we will write that down here. Let's write down what goes together. So h asymptote and domain go together. Oops. In exponential functions, remember, k asymptote and range go together. And those are your notes for today. Have a great day, Algebra 2 students.